Hello everyone, in this video we are going to do something quite interesting. We are going to make use of x-intercepts, that's it, from the information that is provided to us, and create a quadratic equation. Now there is a formula that you can memorize. By the way, we are again going to use soccer as the real world example and apply this formula. But there are a few things that as a prior knowledge you need to know. So when you have x-intercepts and you need two x-intercepts, in this case if it is P and Q, as you know the intercepts are written in the form of showing the y as 0. So you should know where the y value is 0. So in other words, my intercepts would be written as P comma 0 and Q comma 0, because the y value at an x-intercept should be 0. That's a known knowledge. First, we are going to identify them. That is a step 1. And the step 2 is we need to find the value of a, which is the leading coefficient that will determine whether the graph of this quadratic equation will open upwards or downwards. But we know that in soccer it's going to open downwards. And also it determines the width. All right, so I'm going to talk about these few things, and then finally rewriting your equation as y equals ax squared plus bx plus c, which is the standard form of quadratic equation. So there are 3 steps involved in this, and that's what I'm going to talk about. So your question looks something like this. Let me read the story now. So there is a professional soccer player, and the challenge is that they are giving us some information on what crossbar he has to clear and how far the kick has to be. So we are calculating this. So a professional soccer player wants the ball to be just cleared at 2.4 meters crossbar and land exactly 30 meters from the kick. Now remember, when you are kicking the soccer ball, it is a trajectory motion, something like that. So there are a few things happening here from what I just said. So it's starting at 0 and the distance have to be 30. So here we are still writing on x-axis as our distance, and this is going to be our height in meters, and they want to clear a height of 2.4 meters, and they have to travel a distance of 30 meters. And if you have time, we'll also use time on our x-axis. So this is our x-axis and that's our y-axis. Now we need to extract our quadratic equation just with this information. So let's see. And then we are going to graph. Once we get the equation, it's easy to graph. And then we are going to determine the maximum height, and then what are some satisfying conditions to our equation model, and we will conclude our question from there. So this question involves for you to have a knowledge of factorizing, solving quadratic equations, what is vertex form, a graphical interpretation, a projectile motion, and we are using a real world modeling. So this would be like in the application phase of quadratic function. So before that, we have to develop many skills. So check out the other videos while I'm showing all these skills that I just mentioned as a prior knowledge to this question. So for now, I just gave you, with just 2 intercepts, this is the formula that we are going to use to get the equation. So let's begin. Sorry guys, it's been a bit of a tricky day today. All right, now at the ground, the values are 0, 0. The ball has to travel a distance of 30 and 0. So these are your 2 x-intercepts. So my x-intercepts from the problem are as mentioned above. One is 0, 0 and 30, 0. So this is your P, this is your Q. Since the ball starts and ends on the ground, our roots or your x-intercepts, as I mentioned, your P and Q are there. So now using the above formula, it can be written as A times x and x minus 30. So where x represents the horizontal distance and y represents the height, both are in meters. Now, using the crossbar situation, the midpoint distance is 0 plus 30 divided by 2, which ends up being 15. Okay, so it's 15 meters is the half distance. So our x value at this point, why do I need this number? Because I am calculating the height at that point has to be 2.4 meters. That's what they want. So this point location right here is 15, 2.4, and those are the numbers that I'm going to use. So your halfway distance, or your x value right there, is going to be it, because a ball just have to clear a crossbar at a height of 2.4 meters, and the distance to reach that is 15. Okay, so your y is 2.4. We don't know our leading coefficient yet. Your x value at that location is 15, and this is 15 minus 30. And this would end up being 2.4 is equal to negative 225a. In order to find a, you would divide 2.4 divided by negative 225. This is equal to negative 0.01067. The final step is, once you have your a, you're going to go back and rewrite your equation with all the values that you have. So resubstitute it. So your equation is going to be y equals negative 0.01067 x times x minus 30. If you want to round it off, we can do negative 0.011x, depending upon the number of decimals that it is going to ask. Negative 0.011x times x minus 30. Now, expanding this equation, you can also write this as y equals negative 0.011 x square minus negative of a negative, actually, sorry, that's a positive, roughly 0.32x. Alright, so that is my quadratic equation right there. I'm just trying to get the graph. Let me try one more time. Y equals negative 0.011 x square plus 0.32x.